Up, I believe, is Sam. Yep. So now we're going to hear about human doctors and human bodies.
Yeah, finally.
That's going to be cool. All right. Maybe that one and that one.
Yes, maybe. No, I believe without that I can't do it even.
But then we
Right.
don't. We're actually recording sound, if you don't mind, or
Then it's a little bit hard.
or you can do if you want to wait a bit. You can get the.
No, just let's go to first one. Can you bring it to first? Yeah. So, I'm Sam, CEO of Meditex. Today I'm here to just sharing my journey in implementing XR in transforming medical education, something new and much more powerful. So, let me take you back in when I was a student in 2015. We faced lots of challenges with learning abstract concepts of especially basic medical education, such as anatomy, microbiology, and so on and so on. Then it wasn't just only me, actually. All the students across the board had same problem. And believe me, even it was hard for teacher to explain it and transfer knowledge to the students. I used to teach in university as well. I was a student as well. Take my word, it's frustrating for both with the traditional tools that they have in hand. Imagine just you are a student in medical education and you're hearing just some word, lysosome, cytoplasm, yes, chromosomes, lysosomes. Yes, I can go more and more. It's confusing. It's just word. So imagine instead of just hearing those words, you can experience, you can step into cytoplasm. You can see all the components, how they are work all together. You can imagine them. You can have it visualized. And it's not all the stories, right? Your teacher still is with you to explain all the components and what's going on there. So the simulation right now, you are seeing it. It's back in 2015. It was the first project we started. We found it really successful. We concise 3 months of education just in 3 minutes. And guess what? Even the score of students that using our simulation was higher than those who didn't use. We researched it, we published the article based on it. Then we started to create something more as well, from simulating XR for like laboratories, like viruses, psychology even, and it never be a stop. We keep innovating. So let me again back you in the first time that I'm going to launch this technology in the biggest event in medical education. Guess what? In 2015 it was, and people was make fun of me. Not usual people, professors in medical education. They saw me, a kid with a toy in hand. They were making fun of me, and I just stepped back and figure out what's wrong. It was validation. Then I had 1 year to prove what I'm saying. I back home, I did research on my project, I publish articles and take back in that event. 3 times in a row, we won the highest level of award in medical education, 3 times in a row. And our station always was the most crowded. I was the kid, they made fun of me, but now they're using our application. So we are scaling Meditex from research project. Right now, 72 universities are using our application. Just for your hint, just a hint, 550 universities we have just in like whole the Europe reach 72. It means more than 72,000 students right now using our projects. But to be honest, we don't support, we don't update, because it's not our way. It's not our business model. All is for free. They can use it. They can develop it by themselves. So, but we believe the future of XR right now is happening with AI. So we pivot in augmented reality rather than just virtual reality. We work on virtual reality, holograms, metaverse, and so on. But we found augmented reality very interesting for users, easy to use. But lots of obstacles to use those core that right now are available. Then we are going to create AI core for XR. It's open source. It would be open source. The niche market is medical education. We keep focusing on anatomy. Our ML were trained by anatomy, whole body of anatomy. We started with male. Just basically, the thing is AI, check the picture, check the target, understanding it, analyzes, create the nice prompt for our backend, communicate. The 3D models were called, and components comes all together and then showing it to users. It's open source and it could be learned for foods, for other trainings. Every industries can happen. It's still free to use and expanding. Hopefully we can go for pets and so on as well, right? So just a quick hint of what I learned so far. In medical education, if you want to step in, first of all, you need the validation. Second of all, you need to find a real problem. Make a good solution for it. Because it's not a thing, medical education, to just accept you. They are far from technology, and they don't want to let the traditional ways go. Then you need validation, always. Then early enough, just validate your idea with the picture, with the students, have professors of witness. And the good thing is to have and build partnership with universities and publisher of book in medical education. They push you into the market for free. And the last thing, keep innovating. If you want to be a curve of technology, then you have to keep innovating to be always accepting. So it was really short speaking. I keep it short. I didn't want to make you bored. Looking forward to connect with you all to making the future of AR core really interesting. If anybody wants to help out, we are intimate to them, welcoming. Medotex right now, it's in A series. We just raised the funds for A series. We're growing fast. The headquarters is in Canada. Development side is in Iran. And hopefully we are expanding. Hopefully we could expand to the whole Europe and the Canada and America as well. So let's connect each other. Any questions? I hope I just a little bit was inspiring maybe for you. Thanks so much.
Questions, anyone? Not to have one. So I know that you also did some, you also had to create your own human anatomy models because they are very notoriously inaccurate. Is that true in 3D?
Yes. Right now we
Can you describe that a bit? Yeah.
Yes. Anatomies that right now is available in market. There are some 3D anatomies, but some of them are not validated by universities, and it's not based on knowledge sometimes. What we did is to have 3 supervisors across the board to just supervising our anatomy 3D model. Then as soon as we create something, we check with them. Now we have whole anatomy of men, skeleton, muscular, vessels, and nerves. Right now is 70%. We are expanding. The next step to go for neurons, all like synapse and whole the neurons gonna be modeling. Yes, it's correct.
So this is like a digital twin of a human, kind of. But can you also scan it, or you have to model it from scratch? Kind of?
So we model it from the scratch, even if we could just use 3D scanner to scan it. But as the usual and the real bones and other muscle, real muscle are not available to just 3D scan it. The bones is available, but are not good to learn, actually. It's not clear because it's real bone from dead bodies, right? My 3D modeler have it in hand sometimes. For example, for femur, it's actually here, this part. They take it home and use that to 3D, to make a 3D model on it. But I don't call it a digital twin, maybe. I never thought about that like this.
Cool. Any other questions? Yeah.
Yeah, I just have a question about the digital model of human body. Can you scale your model? I mean, is it possible to scan a real person and then scale into your digital twin so that your anatomical digital twin would could like represent any real person?
So right now what we focus on is not actually the creating 3D model of anatomies or humans. What we're focusing on to training our ML, okay? Then I never thought like this, that we could make some part automate or scanning and using MRI systems, or these are, I believe there are a lot competitors in this case and they are working. We even could maybe collaborate with them, use their data, but I never went for it because what we are creating is optimized for our ML, for our application that we decided to create it from the scratch. Sorry.
Yeah, it sounds like maybe to get in touch with Ready Player Me. I know they are doing avatar technology, which kind of can morph, you know, different humans and body types and everything. Yeah, that's like half joke. Yeah. Arthur, yeah.
Just a comment, in case you need the scans, there is a company, I think originally from Ukraine, but right now based in Estonia, HQ Software. We have tried to get CAT scans into the VR, and they're working on some pretty advanced tech, how to get the cloud, like point clouds into the cloud and into the headset. So in case you need connections, just hit it.
Great to know. Thank you. Thank you for that suggestion. I go for it.
Great. So thank you very much. Now a little gift bag, and then it's time for our final speaker.
Thank you.
Woo!